Your assignment yesterday talked about grouping. Okay. When we group things, that means you're just putting parentheses around the first two terms and the second two terms. What this does is it allows you to factor things out. Okay. Now, factoring with a lot of different terms is a little strange, but what you need to do is you need to make it so that both your binomials are the same. Okay. In this case, the common factor between 4x cubed and 2x squared is 2x squared. Now, if I factor 2x squared out of both of them, you'll end up with x plus 1. Does everyone understand that? Any questions? You're right, 2x plus 1. My apologies, Cassidy. 2x plus 1. Because 2 divided by 2 is 2. Got it, Cassidy. Okay. The other one, you can factor out a -1 from both of them. Because remember, you got to make the number inside the parentheses the same. So I'm going to factor out a -1 out of both of these. And I'll end up with -1 times 2x plus 1. So now that I've done that, you'll notice that these are both the same. And you'll notice that I have these other terms that I factored out. So now when I set up my two binomials, the first one is going to be the two circled numbers. So 2x squared minus 1. And the other one's going to be the underlined numbers, or the two numbers in the parentheses. This only works if both of these are the same. If they're not the same, it's not going to work. So the other one is 2x plus 1. Did anyone get anything different that they thought was correct? If the two parentheses are not the same, they cannot be grouped, Chris. Now, sometimes that does happen, right? If you end up doing this, and you've tried it a couple different times to make sure you didn't make any mistakes, that you ended up with different things in here, then they can't be grouped. There are other ways to solve or to factor these. Now, Zoe, it doesn't matter. Did you have both of these binomials? The order doesn't matter in them because multiplication can go both ways. Now, back to what I was saying though, is if you can't group them, there is another way to do it, and we're going to learn that in our next unit, which I'll talk about later. Okay, Chris? Dante, what did you end up with? You said you got something different? I want to do one more problem. Was there any of these 4x squared? You didn't factor out the 2x, and remember they got to be the same, okay, Dante? You didn't factor out the 4, because remember 4x and 2 are both divisible by 2. So you need to make sure you do that as well. Of these 4 problems, which one was the most challenging? So write a number 1 to 4, and that's the one we'll do next. I don't want to do all of them. Okay, I see a couple 3s and a couple 4s. So let's go over number 3. And if we need to go over one more, we'll go over number 4. So let me clear this. Okay. So number 3. Again, parentheses around the first two terms, parentheses around the second two terms. Now, 24 and 6 are both divisible by 6. But if I divide them both by 6, I might not end up with the same thing here. Sometimes you got to think about what the common factor is between all these terms. And in this case, it's 2, right? So if I divide each of these terms by 2, that might help. What I would always recommend is going first by whatever you can divide each of the two terms by the most, and then work your way down from there. So in this case, 24 and 6 are each divisible by 6. So if I do 6x squared, I end up with 4x minus 1. Okay. Now, each of these terms are divisible by 2. And if I divide them both by 2, I will end up with 4x minus 1. So 2 4x minus 1. Okay, and now again, you will notice that we have the same terms on the inside and two different ones on the outside. So now all you have to do is combine things. 6x squared plus 2 4x minus 1. And that's how you end up with that answer. Now, I know it is difficult, but the one thing I need you to remember is it's just greatest common factor. That's all you're doing. It's the greatest common factor over and over and over. So if you think back to like 6th grade when you learned greatest common factor, or even some of you may have learned it in 5th grade, it's the same concept. It's just with variables, and then you just kind of combine things. It's just a different way to look at these problems. Now, one thing that was brought up was in the beginning when I had everyone unmuted. Anaya asked me, what's the purpose of this? So when you start working with quadratic functions and you start working with cubic functions, when we start getting to the third, you actually are going to be asked to set these equal to 0 and solve. Just like we were doing with the ones where it was squared, quadratic functions, you're going to be doing with cubic functions. You can do it with any function to the fourth and infinitely as many different degrees of polynomials as you want. You can solve these. What this is going to tell you is when you graph that function, where it crosses the x-axis. They're called the zeros. And that's important, especially if you're planning on taking geometry next year, if you plan on taking Algebra 2 in high school, which everyone has to take, and if you plan on taking any college level math, which every college requires you to take a college algebra level course, whether that be college algebra 101, whether that be, I don't know, calculus, or if whatever career you want to go in, you're going to have to take math in college as well. So there's a trajectory there where you're going to be using this significantly throughout your time as a student. Would you like me to go over number 4 as well? Either write yes or no in the comments. Only 3 people said anything. I want everyone to tell me yes or no. Okay. We're going to go over the 4th one. And I know some of you wrote yes, some of you wrote no, but I think we need to because I want to make sure that we understand it. Okay. So again, you split them up. You could take 9 out of both of these. 9x squared. Now, when I divide 9x cubed by 9x squared, I just end up with x. 36 divided by 36x squared divided by 9x squared is 4. So x plus 4. Now, it's important to recognize that it's x plus 4 because in the next one, you have two negative numbers. So I need to make sure that my answer, whatever I divide them by, gives me positive numbers. And if I divide negative 4 and negative 16 by positive 4, I'm going to end up with negative numbers. So I need to make sure that I divide by negative 4 on both of these. So negative 4. And if I do it negative 4, I will end up with x plus 4. Now what happens is I again end up with the same thing in the parentheses and two terms on the outside of the parentheses that will be combined. When you combine them, you end up with 9x squared minus 4 times x plus 4. That's it. Any final questions before we move on to our new topic? I'm glad it makes more sense now, Jillian. That's the point. Okay. If no one has any questions, we'll move on. There will be a new topic, and we're about to go over it right now. So what I'd like you to do is make sure you have your notebook open because quite a bit of notes you're going to be taking. Okay. This topic is called completing the square. It's a lot of terms, or a lot of steps, I should say. But we are going to do a few practice problems. So make sure you have a piece of paper, a pencil, and a calculator. Write down these steps, and we'll go over quite a few different examples. And then I'll make sure you do one on your own before we leave. So the first step says to divide the coefficient. That means if all of your coefficients have a common factor, you divide them all. Now, these steps might not make any sense just in word form, but when you see it unfold, it might make a little bit more sense. When you're finished writing all this down, you're ready to move on, type "I'm ready" in the chat. Okay, so let's look at an example. Okay. So let's walk through this. So here's your trinomial. Trinomial means three-termed polynomial. Okay. X squared minus 4x minus 6. The first step is to make sure it looks like this. So you need to subtract your C term over. Okay. So in this case, we'll add 6 to both sides. So now we have x squared plus negative 4x equals 6. First step, done. The second step, take that negative 4, which is the coefficient of your b term. Because remember, it goes a is the coefficient of your first term, b is that one, and this one is c. You take your b term and you divide it by 2. So in this case, it's negative 4. We're going to take negative 4. You're going to divide it by 2, which gives you negative 2. And you're going to take that number, you're going to square it, which gives you 4. Just like when you solve equations, you have to add 4 now to both sides. So I have x squared minus 4x plus 4. And then I have equals 6 plus 4. Now, these last two steps, I want you to kind of ignore for right now. Once you get to 6x plus 4, then you factor this trinomial to get x minus 2 squared, or x minus 2 times x minus 2. This is called a perfect square trinomial, meaning this term, or it's going to be x minus 2 squared, meaning it's going to be the same two binomials that you'll be multiplying together. That's not really that important, but you could write it as x minus 2 squared, or you can write it as x minus 2 times x minus 2. Now, they solve it writing it plus or minus the square root of 10, because remember, when you solve using a square root, it's plus or minus. But for right now, I just want you to kind of focus on getting to this point. Type me some questions. What was confusing about that? What do you want me to tell you? I can help you out before we do another example. So this solves again for the same thing for Chris. This is the same as when we were doing the factoring. You still solve for 0. Now this works, Ozzy, because you're doing the same thing to both sides, right? I added 6 over. I didn't do anything different. I added 6 over, and I divided the b term by 2. So and as long as I make sure when I add that 4 from step 2, as long as I make sure I add it back into both sides, my equation is still balanced. It's the same kind of concept as when we were solving for x. It's the same thing right now. Now, Alexander, we'll do another problem, and maybe it'll help clear things up a little bit, okay? Does anyone have any other specific questions before we see another example? I know it's a little tough. It's a little bit of a confusing concept, but I wanted to teach this to you instead of giving you a video, because this concept can be a little challenging. Okay, let's move on. Munoz, not today. I'm going to give you the IXL tomorrow. I wanted to give you a day to let this soak in. Okay, here's my example. So I did this in 1, 2, 3, 4 steps. The first step is to subtract 5 from both sides. Okay, x squared minus 8x equals negative 5. I then took the b term, which was negative 8. You divide negative 8 by 2, you get negative 4. And then you take that number and you square it to get 16. Now, the reason why this step is strange but why it's important is because it creates a perfect factoring problem to where both of your terms are the same. X minus 4 x minus 4. That's why this step is really the only strange one, but that's why it's the most important one. Okay? Once you come up with the division, get -4. Once you square -4, you get 16. You need to make sure it goes on both sides of the equal sign. Just like when we were adding or subtracting or dividing, whatever, you do it to both sides of that wall. You divide it by 2, Alexandra, and then square it. That's how you create a square number of the B term. That's where we got 2 from. That process gives you the perfect square of 16. What you're trying to do is trying to find 2 numbers when added together that give you -8 by working backwards using a perfect square. Ask me some questions. I think once you try it, it'll help you out a little bit. I know you're still utterly lost, Cassidy. I'm going to give you a problem, and I want you to try it on your own. So, Zoe, there is not a chance you can use this method every time. That's one of the reasons why I'm teaching it to you. In factoring, there'll be some times where you can't factor, but there will always be a perfect square. It is a little bit confusing. I know, Nathan. Okay. Now, the next one, I want you to write down the polynomial, and I want you to try it to the best of your ability. Okay? And then what we'll do is I will solve it with you. I'll give you 2 minutes. Try to get as far as you can. Okay? And then we'll go over it. Okay. Write down this polynomial. Try your best. Okay, Dante. You divided 12 by 2 and got what, Dante? Okay. Square that number. Dante, that would now be your new polynomial. Okay, I want you to pause for a second. We're going to go one step at a time. So pause working. First step, subtract 4 from both sides. Now remember, it is always easier to factor. So if you can see that you could factor this, do it. But in this case, you can't. There's no factors of 4 that when added together give you 12. It doesn't make any sense. That's why you can't use factoring on this one. So you have to subtract 4 from both sides. Now we have x squared plus 12x equals -4. our next step, first off, did everyone get to this point? The very first step of subtracting 4 over. Did you get to that point? Just write yes, please. Okay. The second step, and that's probably the step that we're all getting stuck on, is taking this number and dividing it by 2, and then squaring that. So we take 12, divide it by 2. 12 divided by 2 gives you 6. 6 squared gives you 36. 36 is a perfect square. These are called perfect square trinomials. 36 is a perfect square. So now what we'll do is we're going to take and rewrite our problem. X squared plus 12x now you're going to take this number and put it on not just the left side of the equal sign, but also the right side. Now you can't forget about this -4 that was over there. So you're going to write -4 plus 36. I want you to tell me if you got to this point. Okay, so let's go back one step. Did you get 12? Did you do 12 divided by 2? And you got 6. Did you do 6 squared? Okay. Once you get 6 squared and you get 36, that 36 now goes on both sides, because remember, we are trying to balance our equations. Just like in science, you did balancing equations, I think 7th grade. And in 7th grade and 8th grade, this year we've done balancing equations where you subtract numbers on both sides. Same thing. You've got to make sure you do it to both sides of the equal sign or it's not going to be level. Well, I'm going off of what your science teachers have told me, Chris. That's fine with me. Back to this though. Did you guys see? Does everyone see where I get what I do with the 36? Now what you're going to do is you're going to take that polynomial, this side, and factor it. So factors of 36 that equal 12 is 6 and 6. 6 times 6 gives you 36. 6 plus 6 is 12. So we have x plus 6 and x plus 6. Now this equals -4 plus 36, which is 32. Now for now, I want you to stop at this point. You don't have to continue any further. But again, you can continue further because you could solve these. Now, when you see that it's x plus 6 and x plus 6, what that actually is telling you is it's x plus 6 squared equals 32. Now, in the constants of solving completing the square, it needs to be written as this, or else it's not going to come out with the correct answer to the problem. But what I'm looking for you to do is to be able to get from this point to this point. Would you like another problem to try? Okay, the yeses have outweighed the no's, so let's do one more. Okay, slightly different. The first step is to make sure that you can simplify. So divide the entire problem by a common factor. Who can tell me what that common factor is between all the terms? Nathan, you're correct. It is 3. So if I divide each term by 3, this is gone. That becomes 12. And that becomes 4. Now 0 divided by 3 is still 0. Yes, Chris, simplify if possible in the beginning. Divide all the terms by the same number. That includes your answer on the right side. It's not always going to be 0. Sometimes it'll be like 7, right? In that case, you wouldn't be able to do anything. But normally, you're not going to be given a problem like that. So in this case, you divide everything by 3. And now your new trinomial is r squared plus 12r minus 4 equals 0. Go ahead and try to follow all the steps. Complete this problem. I'll give you 2 minutes. When you're done, type done. Can I draw on it? What do you mean? Oh, undraw it. Yeah, sure. Nathan, you can change R to X. That's fine. Doesn't change anything. Okay, let's go over this. So, first thing we did was we divide all the terms by 3. We ended up with r squared plus 12r minus 4 equals 0. You got to add 4 to both sides. So now we end up with r squared plus 12r equals 4. Take the b term, divided by 2. You get 6. 6 squared is 36. R squared plus 12r plus 36 equals 4 plus 36, which is 40. Okay, we're going to pause there. If you got to that point, right, yes. Okay, you all should be really happy with yourselves because that's probably the toughest part. Now what you're going to do is you're going to factor this. Factors of 36 that give you 12 is 6 and 6. So r plus 6 times r plus 6, or you could just write r plus 6 squared equals 40. Now, tomorrow, your assignment's going to be getting to this step. And I'm going to give you a video on how to solve it from here. Okay? If you did it right, I'm really proud of you, because I know this is challenging. I know it was tough the first time I showed you, but it is a really challenging concept. So I'm really happy that you guys are starting to understand this. The problems tomorrow, I'm going to give you them, and I want you to get to this point, and I'm going to give you a video on how to solve it further to end up with r equals. Okay? But that's it for me. So I'm going to stop recording, and you have the opportunity to